Hello everybody, how y'all doing? Today we are going to be going over partial fractions. It is not one of the hardest integrals. It is one of the little bit weird ones that you could miss a couple thing or two when you do them. So do pay attention when you do work with partial fractions. What does partial fraction states? Okay, so when you want to integrate something like this, there's a rule that says an integral of 1 over x is ln absolute of the denominator. Okay, so when we're doing something like this, we can say that this, so if I were to rewrite this would be 3, 1 over x minus 1. And so I can do ln absolute of the denominator. So the 3 will stay, and I'll do ln absolute x minus 1 plus ln absolute, and this is this denominator, which is x plus 2. Alright, and this is fine. But this only works when you have a linear. So when you have like just x. If this was 1 over x squared, the way you would integrate this, what you'll do is x to the negative 2. This is rewritten, same thing. And if I want to integrate this, what I'll get is x to the negative 1 divided by negative 1, which means negative 1 over x. And that is my integral of 1 over x squared. So this ln rule only works when you only have 1x. You can think about it that way. All right. And so when we're trying to do something that looks like more of a quadratic in the denominator, how can we do this? And one way you're going to learn is when we do partial fractions is you can factor, and then you can use partial fractions on top. And so, see, if we take this and we factor it, let me see if there's a similar, oh, okay, we're going to be doing it down here, so I'll get to it. All right. So how do you do partial fractions? All right. If you have a linear at the bottom, which is just 1x, then you can write it in this format. If you have a quadratic, where like it's an x squared, then you would use this format. All right. And now what does it mean? So you see, I'll take one of this, and this is going to equal a over x plus 3. That's one of them. Now the second one, plus b over x minus 1. And if there were more, like more functions, then what I'll do is you keep going. Plus c over something. Plus, d over something. You keep going until you cover all of them. So in this case, you see what we can say is a equals over x, x, and then plus b over x minus 7 plus c over x plus 2. All right. Now, when it comes to something like this, where you have a squared, you see, this is not quadratic, because if I take this and I expand it, I'll get, x plus 5 into x plus 5. That's what this square up there means. So the way you rewrite this is you'll do a over, so first I'm going to go with the lower power, x minus 9, right? And I'll do plus. Now, because this is squared, you have to do b, and notice, I didn't use this format because this is not quadratic. There's still in here, there's still 1x inside. It's just, there's two of them, right? And so you still use just b, and you would go x plus 5. See, so I covered it once. Plus c x plus 5, and this time it's squared. So if this was number 3 instead, I'll have one of these, then I'll have one of these, then I'll do plus d over x plus 5. 3. And so you keep counting up until you cover all of them. All right? That's if I had 3 of them. Now, this bottom one, you see, I do have this quadratic. And that's where I'll use this format. And so this becomes a over x plus 2 plus a, well, now I'll use b, xc plus c all over. So I use this, just different letters, because I already used a. And this will be x squared plus 16. Capiche? It's pretty straightforward, I'd say. So you see now, I have quadratic plus a power and another power here. So how can I rewrite this? It will be a over, I'm going to start with this. So that'd be 3x plus 7 plus b, 3x plus 7, to the power 2. plus c. 3x plus 7 to the power 3. Now we finished that. Now we're going to go to our second one. And this is quadratic, so what I'll have to do is, so c d, oops, that's a b, dx plus abcd. Guys, I do math, not English. All right, and so now what I'll do is my first one, which is x squared plus 5, and I'll do plus fx g, well, fx plus g all over x squared plus 5 squared. All right, and that's basically how you do it. Now there's a couple more steps that we're going to cover. And so now we're going to start from the beginning. If I give you something that looks like quadratic here, what do you do? Right, so what happens is we'll take this, and first we gotta factor and make it look pretty. So we'll get the integral of 4x plus 5. The top stays the same, right? The bottom, however, if we were factor this, what you'll do is something that multiplies to -2 and adds up to this imaginary 1, +1 and -2. So I'll multiply to -2, -2 and 1. If these multiply, I get a -2. But if I add them up, I get a -1. So if I make this positive and this negative, if I multiply these, I get a -2. If I add them up, I get a +1. And this is my factor. So I'll have an x plus 2 and an x minus 1. You see, now it's in the format that we've been seeing right here. So what I'll do is, so I still have my dx. I will say now I'm going to continue this here. I'll say the integral of 4x. So actually, sorry about this. You don't say the integral right now. We're not trying to integrate it. We're trying to simplify it in a way so that we can integrate. All right. So the integral does not equal this. What we're going to say is 4x plus 5. The function of x plus 2 and x minus 1 equals my, so a, this is not quadratic, so just x plus 2, plus b, the bottom is also not quadratic, so we're going to use x minus 1. Now, after we've gotten this, what can I do? These two are equivalent to each other, but I need to find what my a is and my b is. These are like constant variables. I got to find these constants. How can I? I can get rid of the denominator if I cross multiply, right? So I'm going to take this, cross multiply. So I'll get 4, so I'll zoom in. I'll get 4x5, oops, plus 5. So the left side will stay the same, right? And this is x plus 2, x minus 1 equals. I'm going to cross multiply. So I'll have a times x plus 2 and x minus 1 all over x plus 2. All right. And this is plus, same thing on b. All right. Now, what you do to the right side, obviously you have to do to the left side. So I'm going to also multiply this. There you go. All right. And now, as you can see, these cancel out with these. You have this canceled out with this, and you have this cancels out with this. And that's a good thing, because it makes the way we approximate this a lot easier. Or sorry, not approximate, but find out constants. So now what we get is 4x plus 5 equals a times x minus 1 plus b x plus 2. Now how can we find our a and b? You can find ways. So now what you could do is you could find ways to make one of the either b or a go to 0. All right. And once you've accomplished that, you can basically solve for the other one because you got a variable, right? And so here's what we'll do. We'll do then x. Where can I put my x so that one of these, either this goes to 0 or this goes to 0? So you see, I can make it 1 because 1 minus 1 is 0. Makes this whole term go to 0. Or I can do -2, which will make this whole term go to 0. Right? So what I'll say is x equals 1 because 1 is easier to deal with. And so now 4, you see this side, the x turns into 1 because I said x equals 1. Or it shouldn't be x equals 1. It's more like x at 1. How do you? Whoop, x at 1. All right. Equals plus 5 equals a 1 minus 1. You just sub this into all of x variables. So 1 plus 1, this whole thing goes to 0. And now we have 4 plus 5, 9 equals b. And I add these up, I get 3. Now 9 over 3 equals b. And you see, now that I found my b, I can take it and I can substitute it into my a to really find my other variable. And so let's simplify here. Actually, I'll start now for my a variable. I'll say x at, well, here I don't even gotta do the at. I can just sub it in. But then I'm also missing an x. So I can sub my b in here, right? But I also need to figure out my x. So I'll do now a at -2 equals, or dot dot, or my x turns into -2 plus, sorry, my x turns into -2 plus 5 equals a minus 2 plus 1, or is it minus 1? Minus 1 plus b, and then what I'll get is -2 plus 2. And as you can see, I'm writing upwards. I don't know why. This whole thing goes to 0. And 4 times -2 is -8. -8 plus 5 is -3 equals, so -2 minus 1 is -3, so -a or -3a. And now when I divide, I will get 1 equals a. All right. Now that I found these two, what can I do? I take them and I plug them into my original equation, because I said this whole term, what I said here, I said this whole term equals this whole term. And now since I found my constant, I can replace this instead of the integral of this. So what I can basically say is my integral, you see I said now this equals, right? So this would be a x plus 2 plus b x minus 1 dx. Well, obviously I have found my b and a. So now the integral will be 1, because that's my a, plus my b, which is 3 dx. Now I can integrate this, and all I'll get is just a ln absolute x plus 2, because this is not quadratic anymore, plus ln x minus 1. And obviously don't forget your 3. That comes from here, plus c. And we've integrated. So all you gotta do, the hardest part I'd say is this, just getting this right. After you get this right, everything is really fine. So the rest of these, I'm thinking whether I should leave it for you guys to do, or I should do them. But I'll just run through it real quick. So I would suggest you guys do it on your own, and then do it with me, or watch me do it to confirm your answer. All right. So now what I'll say is 5x plus 3. And what I'm going to do is I'm going to factor this. So 2x plus 1 stays the same. This quadratic turns into x minus 3 and x plus 1. All right. I'm going to say this equals a over, I have a 2x plus 1 plus b over x minus 3 plus c x plus 1. Now cross multiply. And you see, when I cross multiply this by that, I'll get these two to cancel out. So I will get 5x plus 3 equals, so these two cancel out, I'll get a left with these two, right? Plus my b, when I cross multiply this, will cancel out with this, and I'll get these two left. So that will be b. And x plus 1. And now when I cross multiply, my x plus 1 will cancel out with this, and my c will get these two. All right, so plus c, and then we'll get x minus 3 and 2x plus 1. All right, and now that we have this, we're gonna think, well, where can I set my x to be so that it cancels out two of these? Is there a way? So as I can see that this section and this section have x plus 1, but this doesn't have x plus 1. So if I set these to x negative 1, they will cancel out. You see what's gonna happen here? I'm gonna get 5 negative 1 plus 3 equals a negative 1 minus 3 negative 1 plus 1. That looks horrible. That looks absolutely horrendous, but that's okay. All right. And you see what's left is my c. And let's see what cancels out. This goes to 0. Negative 1 plus 1 is 0. So this goes to 0. I'm taking this out with it, taking this out with it. Same thing here. All these will go away. And what I'll get is 5 times negative 1 is negative 5. And then plus 3 is negative 2. Equals c. Negative 1 minus 3 is negative 4. 2 times negative 1 is negative 2. Plus 1 is negative 1. Multiply these together. I'll get negative 2 equals c. And this will just be 4. The negatives cancel out. And so negative 2 over 4 equals my c. All right. Now that I got my c, I'm going to have to basically do this 3 other times. Cancel out my b, cancel out my a. Then I'll get some function, which is in the format of a over something. Sub your a, b, and c in, and just integrate using ln. All right. Because I showed you the example from above, you should be fine with whatever's left. I'm also going to leave this for you guys to do. This one, there's, so you can use partial fractions, or there's a second way you could use. I'm going to leave that for you guys to figure out. Just extra practice. And now, in this example, we're going to use our equation that is up here, this format. And so I'm going to do it since it's different. All right. Now, how can I do this? Let's zoom in. Okay, so my 10 over x plus 3 is the same thing as a over x plus 3 plus b x plus c over, because this is quadratic, right? And so when you have a quadratic, then you can't do this. You have to use this format. All right, so now cross multiplying, I'll get 10. When I cross multiply, this will cancel out with this, and I'll get my x squared plus 1. And now when I cross multiply here, what I'll get is this will cancel out with this, and I'll get my x plus 3. So I'll get b x plus c times my x plus 3. Now the question is, well, what can I set so that one of these cancel out? And if you notice, if I set this to negative 3, this whole thing will go away. And so let's say x at negative 3 is 10 equals a negative 3 squared plus 1, right? Plus b times negative 3 plus c negative 3 plus 3. And so this goes 0, taking this out with it. Now what I'll get is 10 equals negative 3 squared is 9. 9 plus 1 is 10. That's 10a. Divide, divide. We get 1 equals a. All right. Now we got to do the same thing. X at what will give me just one of these. So if I set it at 0, so you notice this little trick. If I set this at negative 1, and it's squared, so I'll get a positive. So there's basically no way I can make this go to 0. But I've already solved for my a, so I don't need to. How can I make b go to 0 or c go to 0 without the other? So if I set my x to 0, my b becomes 0, but my c stays. And so I'm going to set my x to 0, and all I'll get is 10 equals my a is 1, x squared, I set it to 0, plus 1, right? Plus. Now I get b times 0 plus c, 0 plus 3. And you see, now I canceled out this. 10 equals 1 times 1 is 1, plus c times 3. And now taking my 1 to the other side, I'll get negative 1. Well, oh, sorry, this is 10. Let me make this look nice so you guys don't confuse it. There you go. Taking my 1 to the other side, I'll get a 9 equals 3c. Divide it, I'll get 3 equals c. Alright, and I see now that I found my c. What I can do is just plug it into the equation and find my b. Right? And let's do that. Let's say x at 1 this time, because 1 is pretty easy to deal with, right? And so 10, my a is 1, my x is 1, plus 1, plus my b, I don't have, my x is 1, my c is 3, and 1 plus 3. Now solving, 2 plus. Now this adds up to 4, and then when I multiply 4 in, I'll get 4b plus 12, right? And now I just gotta solve, so take this to the other side. I'll get negative 2 equals 2 plus 4b, negative 2 minus 2 equals 4b. Now this becomes negative 4 equals 4b, and I get negative 1 equals b. And see, now I just take this and I sub it up top. So what I'll get is a plus b. Oh, actually, I'll give it some space here. I don't know why I wrote it that way. Plus 3 plus bx plus c all over x squared plus 1. Right, and this is the integral now, dx. I just gotta sub my constants in. So I know I said 1 equals x plus 3 plus my b is negative 1. So this is negative x now, right? Plus my c is 3 all over x squared plus 1. All right, now I'm gonna apply the negative in to make it look a little bit nicer. This is minus x plus 3. All right, now what can I do here? One thing I could easily do is separate it. So what I can do here is so I have dx here. I can integrate 1x plus 3 minus x over x squared plus 1 plus 3 over x squared plus 1. And now once I have this dx, if I were to rewrite it, this is the same thing, integral of 1 over x plus 3 minus integral x over x squared plus 1 plus integral of 3 over x squared plus 1. And the reason I chose to do this is because this one is a little bit tricky. Reason being is, you see, I still have a quadratic at the bottom. So what do? Right? Okay, so basically, since we've split the integral like this, I can take them one part by one. And so here, on this side, I'll just get a ln x plus 3, right, minus. Now, since this is the quadratic at the bottom, I can simply use sub this. So u equals x squared plus 1, and my du equals 2x dx. Isolate. And now when I integrate, I'll get the integral of 1 over u. That looks like a 4. 1 over u, du over 2. And this will be 1/2 because I took the du over 2. Integral 1 over u du, which is just your 1 over 2 ln u. And then my u obviously is my x squared plus 1. And you see now I've integrated this part, then that would be the integral. Right? Now how do I integrate this part? Still, I cannot learn. This is quadratic at the bottom. So I'll do it here. So integral, actually I'll do it up here. So, and there you go. Integral of 3 over x squared plus 1. This is going to be funny. Watch this. The 3 comes out. 1 over x squared plus 1 dx. And in the formula sheet, x squared plus 1 is actually just an arctan. So tan minus 1 of x. And that is your integral. So now we plug it in. Plus 3 tan inverse of x plus c. And that's our integral. Alright, now earlier today we said partial fractions only applies if the highest power in the numerator is less than the highest power in the denominator. What if it's not? So, what do you do if it's something like this? What you want to do is make the top, or make a section of the top, look like the bottom. That's honestly the ultimate goal. So, see if I take this, and if I do x squared plus minus 1 minus 7x, then I have x squared minus 1. You see this section now is the same as this section. And so that is your ultimate goal, is just somehow make the bottom look like the top. And plus minus 1, I'm basically adding in minus 1, so it's 0. I'm not changing anything. So what I can say is now x squared minus 1, I'm going to split the fraction. So see, this is technically what it looks like, right? And I get my plus 1 minus 7x, or this is minus, yeah, this is plus, all over x squared minus 1. Now I can split it using this plus. So there you go. And you see now this whole thing becomes 1. And so what I'll get is 1 plus 1 minus 7x over x squared minus 1. And from here, you can integrate. You could partial fraction. Actually, this might be... Can you use sub this, I wonder? Can you like do u equals 1 minus 7x? And my du will be negative 7. Yeah, that wouldn't work. Oh wait, why did I say that? Oops. What I meant to do is do u equals x squared minus 2. And my du, yeah, that wouldn't work. So you could do partials here. This is an x squared. So you could say, you know, equals a over, well, this would be ax plus b, because bottom is quadratic. X squared minus 1. Right? And then cross multiply, which this will cancel out. So you'll get 1 minus 7x equals a to the x plus b. And now what can you do? Set 0, so x at 0, 1 minus 7, 0 equals a at 0 plus b. And you see what I can do here is this goes to 0, this goes to 0 equals b. And now you take it, you sub it in, you sub another number in, and you go from there. And I'm pretty sure you guys can take it away from here. All right? So now if I go here, how can I make the top look like the bottom? Now, the first thing I got to deal with is make sure they have the same power. Remember, if your power at the top is more than the bottom, you cannot do it, even if it's the same. It has to be the top highest power has to be than the bottom's highest power. So what I can do is I can split off an x. Right? I can split off an x that make it look like this. This is basically the same thing, right? Except now I have 2 squared, right? So now I can say is, what if I add then minus 4 at the top? So x, x2, minus 4, plus 4, plus 2, all over x squared minus 4. Now what I want is I actually want this section. because it matches this section. And so if I rearrange, what I'll get is, let's write my x squared minus 4 first. Now 4 plus 2 is 6, and I still have an x, so this is plus, because this is positive, right? So plus x. Oh, actually, I made a mistake here. Now you see, for this, I have a higher power up top. Now, remember, if the power is the same, so the highest power in the numerator is the same as the highest power in the denominator, then you cannot use partial fractions and you have to reduce it. You can only use partial fractions if the highest power in the numerator is less than the highest power in the denominator. So this is more. So obviously we have to do the same situation. Make the top look like the bottom so we can cancel out and reduce the power. And so if I rewrite this, if I pull out an x out of the x3, what I'll get is x squared. I just pulled out an x. So if I zoom in and rewrite this better, I pulled out an x plus 2. Everything else I'm going to leave the same. I just pulled out an x out of the x, which is valid, because I know it is valid, because if I multiply this in, I get x3 back. Now if I rewrite this, and I say, you know what? I'm going to do plus 4 minus 4. And the whole reason for this is because I want this section to look the same. You see, I've accomplished that. See, these two are the same as this. And now, if I were to rewrite this and make it look pretty, right? What I can do is I can multiply an x in. So let me multiply the x in. So x3 again now. Plus, I'm just doing this for visuals. Plus x4 minus x4 plus 2. And you see now these, if I cancel out these two, I get the same thing back, which means I'm on the right track. I haven't changed the equations. This is valid math. Right? Now I'm gonna rearrange this so that it looks like the bottom. Now I get x3 minus x4, right? Plus x4 plus 2. Right? So now I have this section. Oops, this is not 4 like that. It's 4. Alright, now you see this section looks somewhat like this section, except if I plot an x, I'll kind of resolve my problem, right? And so what I'm going to do, first I'm going to split it using this plus in the middle. So now I have x3 minus x4 all over x squared minus 4, and then plus right? I still haven't changed anything. I just split it into 2 parts using this plus in the middle. Now what I can do is, I'm running this here because I'm running out of space. My x3 and x4, I can pull out an x. There's x's in 2 places. So I pulled out an x, so this would just be 4. And you see, this whole thing is so I can reduce the goddamn power. And as you can see, this cancels out with this. And what I will get is x plus x to the 4 plus 2 and x squared minus 4. And now that the power at the top is lower than the bottom, you can use partial fractions. I'm going to leave this for you to complete. Partial fractions. Oh, there you go. And this x, the integral of this x is just x squared over 2. In case you're a little bit confused. Alright. Now let's try to finish off with an example with repeated factors. Oh, and let's make it definite integral this time so that we know how to work with them. I mean, definite integral, to be honest, you guys, is just the same thing as any integral. It's just you take the bounds, which is this minus this. Now for this one, with an example with repeated factors. Okay, so I'm gonna do this real quick. I'm just gonna set it up and leave you guys to complete it. So I'm gonna do it quick. All right, this equals a over, right, and then b. And remember, this is squared, so you have to write it twice. One without and one with. There you go. And this is all over x plus 3, x minus 1. Now cross multiply. I'll get 3x squared minus 8, x plus 13 equals my a cross multiply. I'll just get x minus 1 plus my b cross multiplied. I'll get x plus 3 plus this cross multiplied. 1 will cancel out and I'll still have one more, right? And so minus 1 x plus 3. All right, and now since this is the case, I feel like I messed up something. Oh, this is supposed to be squared here. Yeah, I messed up something. Oops. This is where I messed up. So this will be x minus 1. Because when you cross multiply, 1 cancels out and you have 1 at the top left. And then for my c, they both cancel out. I'll only get an x plus 3. All right, and now that you have this, you want to choose x at, let's see, what cancels out? If I do positive 1, these two cancel out. So at positive 1. And what you want to do also is x at, so when I do positive 1, these two cancel, I got my c. Now if I do negative 3, these two cancel out, I get my a. Right? And then my x at, how can I get, so I got my a, I got my c. How can I get my b? Is, well, I have my a, I have my c. I can substitute those in. I can choose 0 as my x, so it's easier to deal with. And you can solve for your b. All right? And after you solve for your b, you can just sub in your a, b, and c, and you can integrate properly using parts. Well, actually, this is all parts. So you'll integrate properly all the way up until the last one. And the last one is simple. You just gotta raise it to the negative 1 and integrate normally. So that's the finish of partial fractions. I hope you guys understood the basics, and you should practice as much as you can with these to really get good at them.